Next topic is the pipes in series. Okay, pipe in series. This is the 3 pipe in series Q1, Q2, and Q3, and it's from total Q from the point A. In this case, it's similar to the circuit. For example, you have 3 resistance R1, R2, R3, and for the currents from I is separated into I1, I2, I3. But in terms of the voltage, V is equal to V3. So in this case, you can say that I current, electrical current is equal to I1 plus I2 plus I3. But in terms of voltage, is equal to voltage for the whole the system is equal to voltage for different resistance. So this is similar to the flow in pipes. You can see that the head loss is equal. So head loss is equal to individual head loss, and Q is a summation of Q. Okay. So given a total Q, pipe size and roughness and water property we need to know what is Q1, Q2, and Q3. But how to find this? We start from assume that the flow rate Q1 prime for the pipe 1 is not correct, but it's just to assume. And the next we solve equation to get the head loss for Q1 prime. And we use because of head loss is equal between each pipe, so we're using the head loss for the pipe 1 to estimate Q2 prime and Q3 prime. From the calculate Q from the same head loss. Okay, so we assume that is collects the Q is in each pipe are proportional to Q1, Q2 prime, Q3 prime. Okay, we use this equation to estimate the collect Q1, Q2, Q3 based on proportion to the Q prime summation of Q prime. Okay, Q1 prime summation divided by summation of Q prime. The last step, recheck the correction of this flow rate by calculate head loss for different from Q1, Q2, Q3. Again, it should be equal, okay, or close to. Okay. The next pipe system we call the branching pipe. Okay, in this case there is that pipe 1 connect to pipe 2 at the junction, and pipe 1, pipe 2, and this is and connect to pipe 3 at the junction. Okay. So provide the elevation of water level in each reservoir. We can define the flow rate in each pipe given the type and size of the pipe and property of the water. So the concept is the flow based on the Darcy-Weisbach equation for each pipe, and the junction is based on the Conti equation. It means input to the junction equal to output flow from the junction. So from the higher to lower elevation, so we use the continuity equation facts. The next step, we have to assume elevation of the junction. For example, assume that in case 1, the junction, the elevation of junction is lower than reservoir 1 and 2. Okay, so we expect that is Q1 because junction is lower. Q1 flow to junction and Q2 flow to junction is equal to Q3. Okay, that is if we assume that the elevation of junction is 0.1, but in case of if we assume that elevation of junction is 0.2, it means Q1 is still flowing to the junction, but for Q2 is because of elevation of junction is above the elevation of reservoir, so this Q1 should be equal to Q2 plus Q3. Okay, that's the concept of continuity equation. Okay. Okay, so we already explained from this and assume hydraulic line at the junction. So we can calculate Q1, Q2, Q3 and substitute in the continuity equation. If the summation of Q in greater than Q out, so it means hydraulic line junction should be increased to reduce the flow and increase outflow. Okay, that we have to adjust trial and error for to estimate the Q. And other things, metal loss can be improved by method of equivalent pipe.